Okay, should be back. Brief intermission, right? Okay, let's see. So where are we at? Yeah, so it does not like the node, so we need to be able to forward declare it, and there seems to be some issues with that, and I don't know why. Hmm. So where we declare the node. Yeah, sorry about that, by the way. Something came up, right? Node, so we do have that. We don't need this one, though. Let's see. Alright, well, let's see. So what do we have up here? So we have this. Oh, shoot, we need to do struct in there. That's what I forgot. Struct. Yeah, so we have to declare that. Okay, so just compile now. Yes, now let's see if it works even. We can print the token, it should be able to. We need to actually add type comma. I forgot about that. That is important, right? Because we don't support that yet. So let's add that. Just add it right here. Token type comma. And then excuse me. Where did we put that? It was after the close curly. Receives. Comma. There we go. Yeah, it's just kind of important that we have that. So let's go here. Type comma. Okay, let's make sure that that actually prints properly. It's not handling switch, but that's okay. Int y equals. Wait, hang on. Where is? Alright, I guess we just end there. So I'm gonna assume that it works because it should work. I don't see any reason why it would not. Excuse me. Okay. Yes, let's try actually parsing it. Let's see what happens. So let's just print them all out. 4 times 0 y is less than root dot count. I plus y, and we'll just print the type, right? Root dot data I dot type, and we need to do node types. Like that. Okay, build it. Run that. Expected integer, but found that. Oh, okay. Expected integer, but found. Where is that at? So where are we expecting that? Token type open. Oh. Oh shoot! Actually, am I doing this wrong? Token equals token peep. And then token type that. Let me not print the tokens like this. Get rid of that. And let's see. Okay, because then I'll be able to see it better. Expected integer but found open. Right. So that's when we call expect token, right? So I suppose that's probably in the parse expert. So we won't be calling it wrong. Hello again. Yes, hello, thanks. Sorry about that. Something came up and I had to go, so I'm back now. So I should be able to stream for another, hour or two or so. How you doing, by the way? We might actually need to call token consume. Doing fine. How is your have you started working on like a program language or whatever? Or have you not done it yet? Oh shoot. That's not good. Oh shoot, did we skip over it when we do this? No, we're not in the font call. We're in this one. Okay. Token. Oh, you know what? Actually, that is right. So let's put token consume here. Can't find resource to help. Okay. What specifically are you having trouble with? Because I might be able to help. Try that. No, okay, no, let me look here. So this is line 3. Wait, why is it line 3? It must actually be 4. So this. So, but found open parentheses. So I didn't like that. The fourth thing. Okay. Well, for easy fourth, this is what I used for the spec, like to figure out what to implement. And it's fourth without a U. Yeah. And this is actually, like, kind of have to break it down, but it's really not that simple. Or not that complicated when you are thinking about it. Obviously, it does depend on what, like, if you're using C, it's going to be harder to parse the string and stuff. Yeah. But, so it's like this. I can actually leave a link to this. Because this is very helpful. Because it has, I don't know if it's, like, the full fourth spec, but it is, you know, it's at least a large amount of it. So, like, you push things onto the stack, you can add them and stuff, see? So, like, this is an illustration of the stack. And you can play around with it, get an idea of how it works. Yeah, and it's not too hard to actually implement at least a simple version of it, where you basically just need to split the string. Like, you just read the entire file or whatever to a string and split it by spaces, and you can do most of the parsing and such in that way. Like, in Go or whatever, I think there's like Go string split. Like, I'm just using Go as an example because I know that it has this. I don't think there's something like that in C, but so you can get an idea of what it's like. I think there is split, right? Yeah, so like this, you split by space, right? And that's going to return an array of strings for each one, right? So if we have 5, 3 plus, they would all have a space in between them, right? So 5 space 3 space plus. So it split it into 3 different strings, one containing 5, one containing 3, and one containing plus. And then you can just sort of switch case over, you know, based on if they're an integer or if they're a plus or something like that. Yeah. Hopefully that made sense. You're doing fourth. I am not. No. Whoops. What was that? I am not. I am working on this. Yeah, it is cool. I have implemented some pretty basic like interpreters for it in the past in 2 different languages. But it's a cool language, yeah. Like all the what are they? Concatenative language, I think they call them. It's not handled. This doesn't work. So let's see. Liquid integer. Is it in the var deck? Var declaration. It should not be actually. So we don't expect an integer here. So it must be in this one. I don't know why the location is so messed up. Integer but found type. So why does it do that? But found colon. Huh. This might be wrong actually. Ooh, you know what? We're actually looking at the wrong one. Yeah, so this is not right. So do I need to keep one more? I plus 1. That could be it. So no, maybe not. Okay. Let me handle it in the switch. TT comma, so I get rid of that warning, because that's kind of annoying. Okay. So what do we need to do here? Token consume. Alright, so what are we doing here? Maybe I should print the token type. Tokens. Token not type. So let's do token. Token not type, like that. And that should print the type, the current type that we're on. Let's see what that is. So it's the open parenthesis. Okay. Wait, why is it the open parenthesis? This seems to be I. Wait, is that I before? Or is it I? So it is a closed parenthesis. Okay. So we need to go one more. But then that could be out of bounds. So what we need to do actually is, well, I is less than tokens not count. Tokens arrow count, right? Arrow count plus 1. And that. I think we need a plus 1 there. Because otherwise, then we have an error. Alright, I guess this is not a point, just doing that. And then what we also need to do is if tokens not count. If I equals tokens not count. Then we have an error. So you can print error. lot, no. Tokens, not data, 0, dot location. Expected that, and then I'll expect out expected types. Token type cber. Okay, that means we did not find that close parenthesis. I don't know if that's actually worth it with an echo. The spaces here. That'd be kind of dangerous. Let's bring that. Okay, so then we are on the colon, and we don't want to consume all these. So I was wrong. I was looking in the wrong place for that, right? I said that type colon, but found type right in. Okay, where's that at? Why am I here? Oh, okay, parts. Let's go here. What? Oh, shoot. Something got very messed up. What is this? Did he replace all commas? Or something like that. Wait, what? Alright, something bad happened. Shoot. I saved it now. What happened? What? Stuff is just messed up now. Shoot. I didn't commit anything. Shoot. Okay. I guess not too bad. So TT red. Let's say comma. I don't know what happened. Just please stop. Type count undeclared. What? Type. Yeah, what is this? What? No. Yeah, I have no idea what at all. Once I get it finished, I'll probably make a commit so I could revert to that. If that happens again. What is that? Variable. Yeah, this what? Variable. Have to hardcode every for keyword. Yeah. Well, for each implementation that you need, you would have to create an implementation for it, yeah. Wait, okay. Don't think that's all of it. Okay, macro. Okay, what is that? Type F. Extra. Kitchen node. Wait, what? That would be a fair game. Okay, now there's a lot of problems. Shoot, that is not good. Ah, shoot, dang it. Okay, everything is messed up. Everything is broken. Everything is broken. I'm gonna have to just do it. Okay. What do you see? I need that. Hang on. It is hard. Okay, that's fine. Okay. Yeah, that's not ideal with Chen actually. Oh yeah. Okay, so I basically have to start over. Unfortunately. Freaking okay. Ooh, it's gonna look like this. 2 with 15 and okay. So yeah, let's start over there. Yeah, I need to add all these. Add that. Then we need open. See. What's the other one? And we'll need a colon. And okay. Then we have to parse, or we have to lex it. Name the project pane. Nice. Pane fourth. Okay. Let's see. Data equals open parentheses. Oops, we'll grab that. We just need open. Right, close parentheses. And comma. So this is comma. This is C there. Okay, and then we need to load, so where is it? Yeah, right here. So then let's see this. Okay, that should be it for the lecture. Let me make sure that it works. 0, open array. Okay. No, this needs to be like that. Alright, run it. And we should be able to parse it. So, ident foo, open parentheses, and x colon type, comma. Alright, yes, that was it. Looks like it works. So, let me actually let me make a commit for this. Let's say alright, and I will not push it until I actually finish it. But now we have a commit, so we could revert back to that if we need to. For this, we're going to parse out the but I want to be able to print it out. I is less than root count, plus, and we will just print out root data I type, and we need to do actually node type. Okay, so we got that. Parse. So let's handle this. So we need in tt ident, we have to, if token type is colon, equal, or if token.type equals pt open, then we have a function, right? So we have to do some stuff here. So we need to do the token peek thing. So token peek, tokens I. So let's do something I equals 1, and then while peek I dot type is not equal pt c parent, then we want to do I plus plus. C parent, yeah, and also we need to do while I is less than count. And then we want to do token peek again. Token equals peek tokens I plus one. Basically you do plus one here. So if I equals tokens count plus one, count, then print error exactly 0 dot block. Okay. Expected that we want to provide the type. So tokens, token types, token.data. We want token type. So we're expecting that, right? Okay. Then we grab this next one, which is going to be it's either a colon or not. So if token.type equals type colon, then we know that it is a function depth. Else it is a function I don't know what's up with this. Like that. Alright, function deck. So token.type equals type func deck. This would be token.type equals type func call. And let's move this into a function again. So we need set node equals let's see, parse bar deck, and we'll just pass the tokens in there. And that's going to return all of this stuff. So at that, and that's it. Okay, so we have that. So what we can do node parse bar deck token array tokens, and yeah, so we do this. Okay, just like that, and we will return the node, node, there we go, and node equals 0, and set everything there, and we return. Okay, the only thing though is token, this is an array, so we do this and get rid of these. Okay, there we go. So that is it for that. So we can call that here instead of all this. And we'll call it in a loop here. So, while token consumer tokens dot type does not equal token type C query, we are going to parse the whole thing. So node arg equals parse bar deck tokens. Alright, so that's going to turn the arg, and then we're going to, append to the token, not token, but the node. Let's see, node dot what? No, not that. Func deck dot args, and we're going to append the arg. Okay, that's going to be the nodes. Alright. And then we do the same thing. Well, no, now we need to handle the type. So we can set node.value.funcDeck.type equals inside data 0.value.type. Okay, that should be it for this. Again, it's my second time doing that, but I think I did not forget anything. So I can grab this and do the same thing here, but not exactly the same. Yeah, a similar thing. So we're going to consume it, and we still have to do this, but we are going to parse expression. We're going to return an expression function, and we're going to append that to this, to the function call.args. Okay, and those are all going to be expressions, which we'll evaluate at when we compile it. And we don't need to set the type, so I think that is it. But then we need to token consume. Let's see, this one we need to token consume as well, because we are going to have that. We also will need to check this if the arguments match, if the argument counts match. But we could probably do that during the generation stage. Let's see, we need to token consume because it's going to be like a comma. We do that here as well. Okay, now that should be good. So we need to actually generate the node type, right? So we need func deck and func call. So let's do that. Type. There we go. So let's see, type. Let's do that. Type func deck. Type func call. Okay, so we have that, and we'll add it here. Func deck and func call. Okay, and yeah, so we have that. We need struct func call and also func deck. Func deck. All right, so this is going to have a list of arguments. Let's do func deck arg, and this is the args. So when we make that, type that func deck args, and this would be a dynamic array of nodes. Yeah. Nice the capacity. Okay. Args, and then we also need the type. So this would be type. And that is, oh, we need the name. So bring view name. I don't know if I set that again. I think we have to set it again. And then for this one, we need the name as well. Bring it to your name. We need the args, but they are going to be func call args. No, it's going to be a list of expressions. So expers, args. Let's actually define that. Type that struct expers. Exper. Seems to be that okay. That's exactly data. Count and size type capacity. Okay. So that should be it for that. Do we need anything else? I don't think so. So these are all of the expressions that we need to evaluate when we call it to send up the stack, basically. We do have to declare this. So let's go up here, struct expert, and then we'll add struct node. And then down here, we have to actually say struct node when we do the pointer here. So struct. And then down where we actually have the node, it seems to be struct node, like that. Okay. I think that's it for that part. We have some issues, so that is wrong. 867. It needs to be tokens. And let's actually set the name as well. So type func call, and then we'll set token.value. So we are not. Let's see. So what we need to do is wait. Do we set the value up here? Var.name equals this. Okay, so we can do it in here. So I'm gonna do that. Except this is func. Shoot, but if it's func declaration, we need to do it differently. So what we can do actually is, if it's not a declaration, but if it is, let's shoot, token type colon, actually we might be able to still do it because we don't consume here at all, right? Until we actually get into the function. So what we can do is set it for both of them. Yeah, that'll work. That's for the function call. And this is, no, this one is for the function call. So this is for func call equals that. Okay, build that. And now we have no value named func call. Here, func call. That's it. Okay, so I did not call it func call for some reason. It should be called that. Node type. Hang on. Func call, yeah, and then we have the node value, right? Oh shit, I didn't add them here. Okay, so we need to add the value, so that is going to be deck, func call, like that. Node.value.funcCall.args. Oh shoot, that might not work. 87. Yeah. Okay, 861. I did token again instead of tokens. Alright. Let me add all these. So open paren, close paren, comma, and return. Type O paren. I'm gonna leave the return X because I need to actually implement that. So paren and okay, that should get rid of all these things. From token.type. Oh shoot, we want node.type, not token.type. Node. And node. Okay. Print error, it doesn't like that. Which one is that? Just 852. Oh shoot, I think I need to wrap in a do while. I don't know if I've done that could be the issue. We have another print error. It's like that. 53. No, so it just doesn't like this one. Let's see. Did I? Oh yeah, I see. Okay, that's what I did. Put that. Okay. It's already there. And let's try to run. Expected type colon, but found type item. Okay. Expected type colon. So where do we expect token colon? Colon. Colon. Okay, so in here. So it's an ident instead of that. So we need to token consume one time. That is what the issue is. Before we call this, we need to do token consume. Is that what it is? No. Wait. Let me just make sure I wrote it right. So we have foo. Ident. Why did it do that? That should consume it. This is not one. Oh, alright, let me print the link open right here. Okay, data 0 dot type, and let's do open types like this. Okay. Ident. Yeah, we're on a night. Wait, we need it from this. Okay. What do we do? Open consume. Then it is an open parenthesis. Wait, what? Shoot. Okay, so we need to consume again. Oh, wait. Yeah, because, okay, we need to actually, we need to consume. We consume, the identifier. Shoot, but no, we're saying here, so we need to consume twice, because we have the open parentheses. So that's what we do. We can do it here as well. Yeah. Let's see. Now we can do that. And expected colon, but found type. So from this one. No. So it is it's up here, I think. Ident. So we're on an ident in that case. And that's right. Whoops. I just want to see if it's in this. A loop. How many of those print, right? It doesn't print at all. Alright, so we don't actually get out of this. So this doesn't work. Loop one time. Okay, so it's in the parse var okay. It's not working out. So what is the issue? Our name equals that. Do we expect token colon? I'm gonna type. Why does it do that? Alright, let me get rid of one in the token consume and see what that says. It's a sound. Open parenthesis. That's what it is there. And then we consume one more though. It's actually right. Then the assertion fails. Oh shoot, are we not checking the boundaries properly? Is that what it is? Well, token that count. Greater than 0 and tokens that count. And also here we have to make sure. We're actually looking at the wrong one. Well, tokens that count is greater than 0 and that. Okay. So we print that in there. Let me look at this. Alright, so it does iterate over that 2 times, and that's actually the right amount of times. So then, oh shoot, it's right from this one. No, it's not. So token consume. Oh shoot, but then we have to consume the close bits. Wait. Okay, so tokens count is not within 0. So this one failed for some reason. Wait, what? We have to consume that. Is that Alright, why is it doing this? Let's add that thing back. Oh shit, now it's not. Oh shoot. It's looking for the tokens. I don't want it. Does it go twice now? It does. Okay. And let's try to print the type here as well as here. So type's a type, but then it should get consumed at the end of this, right? Or do we not have that? Do we need to consume again? Okay. That's closer. Let's make token end. See, is it from... Oh shoot, because we don't handle the return. It's probably that. Okay. Yeah, because then we need to actually push onto there for the end, because the end checks. It checks this. Well, no. Wait, what? So where is it saying it? Expected. Expect token. Wait, can we do TTN? Do we expect token TTN anywhere? No. So is that? Is that what it is? Okay, so it's from this. Yes, we need to, because we don't handle that properly, I suppose. Alright, but does this one work? Hang on, so why is that unexpected? So it's probably from this, right? Unexpected token that. Yeah, because we don't parse this all properly. So what do we have to do here? So we need to token consume one time there. Then token consume each time in there. And then consume one more at the end. Bunch of spaces here. Alright, unexpected. So it still something like that. Let's print this here. Let's see what that means. Okay, maybe we don't even get to this point. Or do we? No, so we don't seem to. So we're not supposed to get it consumed. Assertion failed on each. Okay, what is this assertion failed? Yeah. Oh, but we tried to print a type, but it's a type. Oh shoot, in the value. Okay, so it's a type. So we do want to consume there. So that's not what it is. We do want to double consume. Then it doesn't like the end. We need to handle the return. Why does it say end? I don't quite get that. Alright, so let's just handle the case token type return. Token type right. Wait. So basically, let me create a node, right? So node equals, whoops. Dot type equals type right. I don't know if I made that, but we need a type right. And the value equals parse expert tokens. And you actually have to token consume. Token consume tokens. And we can do this. Parse expert and then DA effect. Okay, just like that. That should be it for that. We don't have feature red, and also we need case. Let me spell it right. Yeah, so type. Let's go there. So we need to type red. Red, I forgot about that, so all and then return. Okay, parse expert. Yeah, and we need to add the value here. So the value for it is just going to be an expert, so it can be the same as some of the other ones that we have. So let's go with node values, and let's see which ones we have. Node value. One that is just it can be a conditional. Do we use it? Like if I change this, am I going to get a bunch of errors? Do we use the expert thing? No, so I'm going to set the expert value to that, and then we can probably use that for the conditional as well. I think it's clear enough from the rest of it. Hate GitHub access token? Yeah, it's pretty annoying. But I understand, like, pretty, security is important, right? So I get why they did that, but it can be quite annoying. Value dot, expert. Is that? Okay, so it does compile now. I'm not trying to run it. Big token end. So it still doesn't like the end token. Why is that? So we still get here. Why do we have n? Wait, what? Oh shoot, does this loop too many times? Maybe I should set 3 in TDB because I'm not sure exactly. Break on parts. Okay, and then we will what? Break parts. Right. Okay. Next. So this is declaring it. Then this one is another one. Wait, how many do we have? Let's see. I know we have. Okay, I just ran 2 there, so that's why. Alright, then we should be on to the function. So tt equal. Wait, let's print that type. It is open parenthesis, so we are in here. We go here, and let's print I. Let's print open I. Let's actually display it so we can see it. Display. Alright, we'll keep going through. So that is type int. No, it's type open parenthesis. I see. Type close parenthesis. Okay. Oh yeah, so we just went through the whole loop. Alright. That's fine. I don't know how to unspell. Is that a thing? Yes. Okay. Print token dot type. Is colon, so we're in here. So that's the function declarations. That's all good. Token consume. Tokens dot data 0 type is open parenthesis. Okay, so we're good there. And let's print that again. Tokens dot data 0 dot type is item. So then we parse that, and we're good. Okay, print arg. And we have a lot of data here. Print arg dot. Can we do that? But what is it? Arg dot. Value dot. All right, I don't know how it is structured yet. So it's a note actually. Type is their declaration. Okay, so we append it there and consume tokens. What is the tokens dot data 0 dot type is a type. All right, so we consume it, and then we go through again. And then we go here, and let's print tokens dot data. We're gonna print this a few times. Print the type. So colon. Okay. Shoot. So this is getting set wrong. So we need to token consume before we call this. Data 0 type is token type. Okay, so something we need to do actually is this up here. So we actually want to really expect token colon. We already have it up here, so we're good with that. But that is an issue. But I don't know if that's the issue, right? So I'm gonna go through again. Go here. Token type is equal. Okay. Yeah, because we're assigning stuff. So we go through all that and we're good. And then we have the then, so that's fine. Wait. Why do we have the then? We don't have the then. Tokens. Tokens.data is 0. It's an item. Why are we in the then? Wait, what? Yeah, why are we going through this? What? What? Wait. We don't have a single then in here. So why are we here? That is not right. And that's probably where our issue is. Token type ident, and then what is it? Token is end. Okay, so that is not right at all. I think this might not work. Let me print like that. And we can see what it actually outputs. Get out of this. Yes. Go again. Run it. So why do we have an N? I see. So why does that happen? Okay. I return N. Oh, shoot, this is supposed to be returned. Okay. So that's where that issue was. Why doesn't it have N though? We can try it now, because that would be at least close. Then we segfault. That is at least somewhat better. Let's see if we can just run it. Okay, so that doesn't work. That's on the token type A. So we need to actually push a label to handle this. So when we encounter a then, we push a label, and we need a label for the function. So I think we can just do this basically. Just do this when we encounter a function declaration. But that's not exactly right. So what we need to do actually is push onto the stack that we are currently, or that we define a function, and that's what we're closing. So I thought we had something like that, but maybe not here. We do have the stack of labels, but we need the function, right? So what we have to do, I think we just have a function, right? And we can store that with that. So actually, that's not going to work, is it? What do we have to do for that? Because I want the label should be the function. So we're going to change how we handle stuff. Let's create a stack of types, right? So what do we have? Block if. I think we have that. Yeah, then we need block type. So we'll make an array of block types. And the current one, yeah. But I kind of sort of separated it. So in the generation, we have this, right? And we handle that while we're compiling the code. But the other one we have while we're parsing it. So I'm going to just sort of combine it together, but I don't want to do that right now. So what I'm going to do is just make one here. Block type, block stack equals 0, like that. And it's going to be an array. Well, let's make it binary, right? Let me just do type here. Let's see. Data. And size capacity. So I'm gonna do this again, and then we will define it. So func blocks. This is the block stack, but it's just for functions. So let's do func stack. It doesn't need to be a pointer band, and we can 0 initialize. Okay, and then we'll just push to that, right? And then if the top of that, well, if the count, when we reach an n, if the count is greater than 0, then we're going to do that. So really it only ever needs to be, well, no. Shoot, because if we, yeah, so we kind of need to push each time. So I'm sort of gonna, have 2 checks, but that's fine. So anytime we reach an open thing, so either a then, a wall, actually just an if, a wall, or a function, then we'll push to it. So let's AFN to the, I'm gonna call it the block stack. To the block stack, I'm gonna push block func. Okay, so we have that. But then we also have in the if, we need to do that same thing, but for block if. And the same thing for wall. And probably else as well. Else. Okay, so we had that. And then we're going to pop from it when we get to an end. And if it's a function, we're going to do stuff. Otherwise, we're going to do this thing. So if block stack data minus block stack count equals block if, block func. Then what we're going to want to do is handle it differently. So else we can do this. Okay, else we want to push the current function name. So that is what we want. Shoot, but we don't have that then, because we're storing one of these. Do we need it? Yeah, because we need to be able to jump to it. So that's a bit more complex. We need to change the label, how we handle the label. Okay, here's what I'm going to do. So node.value.label.function equals, we don't have the function name, do we? So we need to store that with that. Shoot, that gets a lot more complicated. Yeah. Okay, so we need to store that with it. So it needs to equal the top of the block stack. So block stack data dot count. So this will be dot type, and this will be dot value. And then this is going to be label dot no. Sure. So we do need to change how this is handled. Label dot none. Let's see, where else do we call that? Dot none. No. Probably just compile. Yeah, let's do that. So let's do node type. And we should have label. Node value. Yeah, label, so this needs to be a label. And type that struct label, and that's going to have its IC. It's also going to have a string function. Okay, something like that. Let's try to build that actually. Yes. Build it. And func stack is on here. So func stack, we need to interact to block stack. Okay, and what else? Value, that is not that. Mine for 2. Yeah, it doesn't have the right because we need to change the block stack. So it needs to be let's just call it blocks actually. And this will be blocks. And this is gonna have a block. So let's do first time here. Hello, how you doing? Welcome, welcome. Glad to have you. What is up? So a block can have a value, which is it's gonna be a string value. And then a block type, which is the type. Okay. Just woke up and you realize that you want to code in C. Coding in C is pretty fun. Pretty fun. I do it pretty much every day, so. Oh, shoot. So when we get a pen, we have to do it differently. Alright, yes, like this, block func, it needs to actually be a block. That's not right. So dot type is that. And the dot value equals name.value.then dot name. Okay, we'll just grab this and we'll put it right there. Alright. Block. So hopefully that works. And then in the other DA events, we have to do that as well, but just with the value. So it's 4:20 p.m. in my country. Best time, best time. What time is it for you? In dev and want to leave the front end world for good. Do you happen to know the job market? I do not. I do not know because I don't have a job right now. So I'm not sure what it is like in terms of 10:30 p.m. day and 3:30 p.m. for Texan. Well, that was actually like for Texan. I could have guessed that, but 10:30 p.m. Dang, that's pretty late. Yeah, thank you for following, by the way. Viginti, is that how you pronounce that? Apologize if I mess it up. Dang, 10:30. I'm usually asleep by 10:30, so. Okay, let's see. What else do we need? That did not work. So what's that? Got it. Good, good, good. Wow, I'm glad. Okay. That doesn't need to happen. Germany is probably far away. Yeah, I'm in the United States, so it's a little far. Wait. Really fun is not sick. Well, it's fun until the next day, right? Depend on declared what? Just takes two. Oh shoot, so it doesn't like this. What is wrong with that? Huh? Tested it to a block. Is that this one? A block font quick. What? I did not pass through though. Block stack. Block. Hmm. Why does it not like that? I'll declare block like this. Block. Block equals. Block. Dot value equals name dot value dot then dot. And pass that here, the block. Block. And somebody named Funk. Yep, it's that, not that. School tomorrow, but don't want to start the code. I know that. Other than slime, seeing something that isn't there in the corner of your eye. Yeah, that can happen when you are sleep deprived. Set fault. Okay, let's see where it breaks. So break main. And then let's see. So run. Let's just see where it breaks at. They pen. Put into that. Shoot. What? That could be how do you about? It's like a log thing or something. Run. I don't remember how it's called though. Run. Help. How do you do we have that. Maybe not. So redirect the log, you know? Log file, okay. Log file. What's out? Main. Let's see. So did it work out? What do we have here? 897. Okay, so it's from that. It's not stacked, mallet, or recently freed. It isn't like this. Funcall.args. Do I need to do something with that? Does it have to be a pointer? Is that what it is? I don't think so. Coming core, that. Okay, yeah, so it's from this. Something like this. Yeah, it doesn't like that. Shoot. It's because it is a double pointer. So what I need to do is. How do I do that? So what I have to do, I have to allocate it first. Well, hang on. So arg, that gets allocated. Let's look at that. So what we have to do is func call, yeah, and then if we look at the func call, which is up here a little, func call, we have experts, but it doesn't need to be like that. Okay, then I can get rid of this. Yeah. Yeah, okay, that's what the issue was. It was not supposed to be a pointer. So that thing, like that. Okay. Alright, then that failed, but that was a different failure, which is a lot better. So let's, do I have that outbound file now? Yeah, outbound core, that. Okay, so token consume, that. Yes, we called token consume and it failed. So where is that at, though? It's not very helpful to see that that's not where it's at. Make this unnecessary though. Maybe that should even be like, is that something that could happen? Because the user, so it shouldn't be innocent. Gonna get some sleep now. Just finished the recursive directory scanning for the file explorer for Kendall. Nice, nice. All right, that is super cool. Have a good night. Have a good night. Where's the other bit? Big parts. Okay, let's see. Which one does it break at? Okay, so right there, token consumes. That was in the in this one. What is it? In the function call. So why is that? Let's look at the function call, right? Do we not need to do this? Shoot, because there's not the extra stuff that, so we don't need that. Is that right? No, we still fail. Still fail here then. Let's print the token type here. Tokens data. It's actually dot data 0 dot value. The dot type rather. There we go. Okay, we can see what it is, right? What the type is. Didn't print anything, huh? Huh. So it failed before we got here. So in here. Oh shoot, I see. Because we consume it. If token heap tokens dot type equals token no, do 0 dot type equals tt comma, then we have to token consume. Otherwise we don't want to. So it is. Expected integer, but found exit. What did we expect integer? Is it in here again? No, okay, probably. Probably in the parse expression. So we call that. And consume dot type does not equal that. So we consume token. Consume all in here. Do we need to do? We don't have to do that. Let's print the token type here. Token type. Tokens dot data 0 dot type. And we can spin it out and see what it is, right? Integer. Okay, so run an integer. So we actually have to consume that one. That is okay, so I have to consume that. And then there's gonna be the other one. Then we want to exit. So maybe exit. Yeah. So maybe it should be exit. So what's wrong with that? So why did we run out of tokens then? So this should be fine, right? Because we consume that one. We consume it again if it's a comma. Print that. Exit, but then we fail here. Where are the other tokens? I don't get that. Yeah, because if there's no comma, don't want to consume it, obviously. Assertion failed. Out of tokens. Why? Let's type through an G. And let's break on this line actually. So 892. And let's run internet. And let's see where we're at. So we go here. And let's print the tokens dot data 0, right? So it's open parentheses. Okay. Then we parse the expression. we can print arg.type, and that is int. Okay, so it's just a single integer. That is what we would expect. We can print the tokens.data 0.type, which is going to be an integer, so we can assume that. And we can print tokens.data 0.type, which is exit. Why is it exit already on the first one? Shoot, wait. That's not good. Okay, let's start over. Wait a second. Wait a second. Did it consume this one too? It could have. If we have ident y, comma, no, ident y equals that, n, ident foo, open, integer. Oh, shoot, we didn't get the comma there. Oh, shoot. So it's just two integers. That is an issue. Right, so when we lexing the integers, I think we consume too many, right? So we have to actually do this again. For here. For the integers. Where are the... Yeah, right here. Alright, let's see. Does that actually fix that? Integer, comma, that. Then we have this. With an integer, but found close brackets. So where is that? Let's run it again. Break on to run. No, right? And okay. Yes. Yes. And we'll go through. Okay, actually, let's see, what does it actually fail at now? Integer. Expected integer, but found close. Where is that? Let me do that again. I think next. Alright, so let's see, we have ident, and it is here. Let's make dot data 0.type ident. Okay, and we set that, so we can see that. Tokens.data 0.type is then equal tokens.data 0.type and ident. Okay, yes, then we're parsing that. Okay, alright, and then we go in here again, and it's return, parse expression. Do that, and then we go in here, and it's end. Right, parse that one. And then after that, we have, yes, this is the function call. There we go. So it is variable reassign. In the function call? Wait, no. Alright, we're here. pt open frame. And we go here, and it's going to be a function call, right? Yeah, function call. Data 0.type is open parenthesis. Go through here. .type. And it's comma. So we don't want a token consume here. So that's wrong actually. Get that wrong. So type. Oh, get rid of that. Okay, but then it's gonna print that out. Integer. Yeah, and then we have an issue. So that's where it fails. Yeah, so quit out of that. And we don't want to consume there, but we do want to consume that one. Let's try it now. We don't want to consume here either. Variable y reference before inside. Oh shoot, because we don't assign it. But it did actually, it looks like it compiled it. Right. And did we print it all out actually? We did. So exit. Why is there an exit at the top? Variable declaration, variable declaration. Wait, what? Oh shoot, that's where we are printing and stuff. Okay, get rid of that. And recompile it and run it again. So we have a variable declaration, function declaration, variable reassign, return, end, function call, and native. So that is actually completely right. So it says y is referenced before assignment because this is the function here, and the y is not assigned because we don't actually handle any of that. But what I'm going to do is actually create a commit for this. Okay, I'm not going to push it. All right, so now we can handle this. So the actual stuff in here. So we need a few things. So we have a few cases. So case type func deck, right? We have func call and func, not func, but which other? Func call and like that. That was already done. Okay. So there's a few things that we have to do here. So when we have a function declaration, we want to generate the label. We want to generate the label. Yeah. But the problem is, I didn't think about this actually. So the entry point, right? We don't really have an entry point, and we want to actually skip over this. So we need to kind of generate it. How do I want to do that? We can generate the entry point main, but then we have to make sure we generate this above that, or after everything else, right? All right, for now I'll just generate it, and then I will think about that after, because we need the main. We need the entry point. Yeah, I forgot about that. That makes it more complicated when you don't have the main function. All right, well, so we need to create a label, which should be stored in there, if I remember. So type that. We create that. We have the value, right? And that is what we need to create for that. And then we have all the args, which only comes, like, we only have to worry about that when we're calling it, because we have to, yeah, so we actually have to push it onto the function stack. So we'll make a function stack. Where did layers of abstraction come from, like, as a name? Well, it's like a reference to, in, like, software development, you add layers of abstraction, right? Like, it started out, like, earlier, it was, like, assembly, right? And then C is a layer of abstraction over assembly and other languages like C. And then a layer of abstraction over that is like Java or whatever. And then over that, you've got, Python and JavaScript and stuff. And it's just like, continuously stacking it, for better or for worse. So it's a reference to that. So that makes sense, yeah. Okay, shoot. So I need, yeah, so in the program, what do we have right now? We have the scope stack. We have the variables. So what are the variables? Because could we store a function as the variables? Let's see, variables is that. So we have the name of the variable, the type, and then the value is an expression. So yeah, I need a function, right? Instead of a variable. So functions. I may be able to make them the same thing, but I'll worry about that later. The function, and that's going to have a name. That's like the variable. And then it's going to have the args, right? Args. So we need to say that so we can actually reference it, right? We need to make sure when we call a function, it is within the it's within the existing functions. Do we need anything else? Yeah, we need the type. Okay. And then we'll just make a dynamic array of that as well. Function data. Okay. And then, yeah, then we need to add that, not there, but to here. So we need, under that, we need functions. And yeah, then we can just append to that. Parse. So when we encounter a variable declaration, let's see, type var dec. No, type func dec, yeah. Then we need to do it then to state functions. Node. No, we just need the function, right? So we're going to create a function here. Function equals 0. It doesn't need a function. So, right? Function dot type equals node value dot func dec. And then function dot args equals node value dot func dec. And then function dot name. Actually, I'm thinking we could use whatever we use for node for func dec for the function. That probably makes sense, but alright, and that should work, I think. Value, yeah, it's not underscore, it's dot. Int. unknown type name funcargs. What did I call it? Yeah, let's go back like that. And where is the func deck defined? Func deck args. Okay, that's what it's called. Yeah, we want to use the same thing, okay? Okay, so that compiles. So let's do type. That's not right. Type func deck. So that should be good for this, right? And then we need to do, for the function call, we have to search the functions, make sure it exists. Yeah, so we're just gonna do one pass for now, so that you can only reference it after it's created. Yeah, and then we will do that. Oh shoot, but we also need to, I forgot, we need to then create the label for it. And then so we need to create the label. Okay. So we will, gen label, gen func label, and we'll pass the function.name. And then also the file. Okay, so I will create that. So gen label, we should have that function already. Gen label, yeah, so like this, and we'll make gen func label. Func label, and this is going to be a string here. So then instead of this, we're going to do wait. Okay. And that should create the function label. Which should be all that we need to do for this part. Then we encounter, oh shoot, we do have to push onto the stack. So that when we encounter the end, we know that it's a function. Or when we encounter the return. So, we should have a stack already. How do we do that? So when we encounter like an if, right? We append to this block if. So we want to append a block func. And then, yeah, so the return is just going to peek the stack, make sure we are in a function, and then the end is going to pop from the stack. But the function call, so we need to first of all iterate over the function. Functions.count, likewise. And if you compare, i3 is the best. I don't know. I'm not using i3. This is awesome, so I'm not sure if that is true. I've never used i3. I know a lot of people that do use it though, so. But yeah, I never tried it. Functions data I dot name, and then the current name, so node dot value dot call dot name. If that is true, then we are good. So let's make a function for this actually. So if not is in funcs, and we'll pass the node dot value dot there. And also the state. Or no, the function. The state, yeah. This is going to be state. And it's just like that. State dot functions. Maybe I'll even pass that to point. You know, we're not modifying, so it should probably be a constant pointer, but you know. So it is in funcs, just up here, and we'll return a boolean. What is in funcs? It's going to take, so it takes the program state, and it already is a pointer, so I need to identify. Dang, alright, backspace, and now I got rid of that. We need to for something to I equals 0, while I is less than state functions, if you compare state functions data I dot name with name, so we pass it in, and return true. Otherwise we return false. Okay, we need a string new name in there, we're gonna pass, and then if not that, then we will print error. We just need whatever location. Whoops. Not type 0 function that reference. I cannot type. Okay, reference. or assign. Assign. There we go. I think I got it. And we need to actually print a view. So view arg, the name. View print. Let me actually move this onto a new object, because I cannot do that. Like that. There we go. View arg node.id.one call dot. Okay. That should be good then. So if not that, then we'll do that. Otherwise, we're good. So it is in there. So we need to actually generate the label to call it. Gen call label file, and then call.name. We want to generate. Actually, it's not really just a label. It's the function call. So we're going to call it, right? Yeah. So we're going to generate the assembly for that. But first, we need to generate all of the expressions that are within there. So we need to for each argument. So for I 0, while I is less than that, we need to generate that. This should also actually this needs to return we'll have is and funcs and then get funcs actually. So while it is less than value.func call dot args I plus 1. So we have the args. And we need to, what do we need to do? We need to generate the stack, but we also need to give the variables a name, right? Push them onto the variable stack with the proper scope and everything. So what do we do when we encounter that? We encounter let's actually function equals function get func. Yeah, let's do that actually. Get func state. We don't need a point of that. And then node.value.func call dot name. This can even just return a pointer to it, and then you can check if it's null. So if not function. Yeah. Okay, so we'll transform this, right? So get function. It's gonna actually turn into a function. Not a function, but it's pointed to a struct called function. Yeah, we will return data I pointer to that. I think I can do that. No, it's a pointer. Okay. Yeah, it does need to be a pointer, so let's do that. Okay, and then we can iterate over the args, and we need to parse the expression, and then also push the variables to there. So type var dec. We need to do this for each one. First of all, not first of all. This is actually second. We also need to generate the parse the actual expression, right? Right. Okay, so there's a lot of stuff that we have to keep track of this. So we need to gen expression for node value dot call dot args I dot that. I think we have that. Gen expr, and then node value dot var dot stack position. Why do we have that? So we need to create a variable for this actually. So variable var equals 0, and we need to do var dot stack pose. This is not important. Stack pose equals state stack size, and that is what we need to push here, and also the name, right? So var dot name equals the function that args I. That's what we want to push. I want to push the var there. So we generate the expr from the value, but then this is from that. The stack, not the stack, the name comes from the function. Okay. And also we need to just check. So if function args.count does not equal node value.count, Then we have another error, so we will print that error. Like that, and then args do not match for function and for function back. Functions dot function dot name. So it be function, not functions. Oops. Okay. Function not name. I think that's good then. And then what else? What else? We append that and we generate the function call. So we need to make that gen. Yeah, func call and then or func label and then func call. Func call. It doesn't need label, so I'm just going to do that. And we will generate call that. Yeah, so it's going to call the function. So let's try to compile this, and node is a pointer, 1147. Node that, okay. Function is a pointer. Why is function a pointer? Function is a pointer, okay. And that, and that. Okay. Subscripted value. Function args. No, that's not right. Hang on. Args data. Data. Node has no member name. Okay. It doesn't have that. What are the nodes? They're variable declarations. So it needs to be dot value. Func dot name. No, dot var dot name. It's a variable. And that's the same thing for the gen export. And we have that gen export. Node value dot args dot data dot value. Okay. Expected statement before that. Arrow value because it's a pointer. Okay. But type is expert value. Oh shoot, we don't need the value. Okay. Just like that. The actual thing. What is that? Call.args.count. Huh? I is less than that. Something like that. And the print error doesn't like that either. Do I need to do something like this? Let's see. Perhaps. Oops. It's not wrong to do that. Okay. There we go. Is defined but not used. What? I'm missing a semicolon or a bracket somewhere. Print error, just like that. Oh, this needs a comma. There we go. It doesn't like that. Okay. And that needs a semicolon. That has a semicolon. Oh, but this needs a, yeah. This is UR. This is the same thing as this. Alright, yeah. And there we go. Huh. What's wrong with that? Print error that. Oh, shoot. Wait, no. UR. Function. Oops. What is that? What? Why did it go all the way back here? Hang on. Type. Okay. Print error. expected expression before that. Doesn't like that for some reason. Let's look at this. Implicit declaration of get func. Yes, we don't have that, so we need to change get func. We didn't change the name, so not easy funcs, but get func. Get func. Get funky, yeah? Not safe. Okay. No, it still doesn't like it. Oh, shoot, because it's spelled this way. I did not capitalize it properly, right? Okay. Okay, expected expression before that. So it's just that. 11:37. 11:37. It's the print error. Function, you print, you are bad. Do we have any other prints around here? Print error that. Patient 0. Yeah, let's just, what is wrong? I don't get it. That's right. Why did that bring no one back here? I don't understand. What? Okay, type. Oh. Right here. Why does it fail? Oh, shoot, because I get backwards, that's why. I see. Okay. Yeah. Yeah, I realized at the same time I saw that message. Yeah. Thank you. Function is appointed. Where do I use function? Is it here? Yeah. Okay, so it compiles. I don't see the word. Variable y, that's for it, but we created the variable, right? In the function. Let's print the variable name, yeah? You print. You are. You are. Yeah. We don't handle the. Oh shoot, we don't handle the return. So that's it. Let me not print all of these. I'll get it. Variable y reference horizontal. Oh shoot. Yeah, because we try to compile that, but it doesn't exist yet. So if we're in a function, okay. If we're in a function and we're declaring a variable, we need to look at the args of that function rather than that. Okay, that's what we need to do. I forgot about that. So type var. So what we need to do is wait. But it's in the gen expert, right? Okay, so gen expert. Let's go to that gen expert. Actual function. Yeah, so it's not very complicated here. So basically, when we counter a bar, get variable location. So we want to, if let's actually get the get func and we get upload. Are you wrapping your print macro in do while loop to avoid wrapping in a block? Yeah. I was having some troubles, and it's easy to look at it like that. But yes, I do that. I do that. At least I'm pretty sure I did. I know it's some of the other ones. It should be though. Yes, indeed. Okay, get variable location. Then we can get it here. So if what? Yeah. So if the top of the stack, right? State block stack. State block stack size minus 1. Well, okay. It has to be greater than 1. State block stack dot count is greater than 0 and block stack dot data stack dot count that's not right. Block stack, there we go. Type equals block. I don't think we have type types. So equals block. Then then we still have to get the, well, hang on. So how do I want to do this? We need to get it based on that. So right. What do you think? Right. So we need like a label here, right? So this is the function. And we need to basically increase the stack size by that amount. Yeah. So right. Right, yeah, so what we need to do actually is we need to push them. Yeah, I know what to do. We need to push them when we counter this. Counter the function declaration. So we need to push them like this. Then we don't want to append them here. We just need to set up the stack properly. So we need the gen expert. And probably the stack size, so we need to actually modify it. And set the stack size equal to when we call it. Yeah, so we need to do that. How do we do that though? Actually. Not sure. Okay. Because we need to keep track of the stack size and use that there and do that. But well, they would be on the top of the stack. Yeah. So actually, the stack position, it doesn't really matter in this case. Figuring that. We just need. We don't even need this. We need to basically move all this stuff up to here, right? All right. So the stack position is that, and that's fine. That's fine regardless because yeah, yeah, because it is relative. It's relative to this, so I think that'll be fine. The name is function.args. That. I'm going to do that, and then we append that. So let's see. Variable var and equate. Where is that? Oh, it should. Okay. Where do we use var? Oh yeah, we don't have var here. This is variable. No, we need a variable. Variable var equals 0. So we need that, and we need to get rid of this one. Call it var. There we go. Okay. Still reference for assignment. So we're creating it though. It just doesn't have the value yet. Because we set the stack position and the name. Let me counter this. So why doesn't that work? But then we need to increment the stack size for each argument. Oh yeah, we need to do this for each argument. Yeah. That's the issue. Okay, so for 0, y is less than function.args. And then do this for each one. Yeah, that's what the issue is. State stack size plus I. And let's see. So there you go. It's just function. Cycle. Okay. So what would be the issue here? Variable stack size plus I. That should be fine. This might be wrong. Okay. Let's try GDB. Yeah, and break. Let's not break it. Let's just run. See if we can see where it breaks. Okay, so it's on the scope end. Oh shoot. So we need to. Wait, what do we have to do for that? So the scope end. Okay, minus scope stack. Do I need to push to the scope stack actually? Yeah, we do need to do that. So to that, so it's the same as a then. To that, the current stack size. Prior to all this. Yeah, so we have to set up all the things. Right? Yes. Okay, so it did compile. And this is obviously very wrong. So I don't know why that would have. Oh shoot, actually. Oh shoot. So we need to increment the stack size each time. And that'll actually be fine because when you type to do end, it'll be okay. Yeah, so that actually will work fine. I think that's what the issue was though. Yeah, okay, so we have that. Because this is in the function. I forgot to we need a colon. Okay, let's try that one more time. So this is the function. And this is all the stuff in here. We don't handle the return though. So that's the thing. We don't need it yet. Let me just see what happens. So if I try to run. 10.10. Stack overflow. Okay, that's actually interesting. So we might not be able. Let's see. So that means we got stuck in a loop somewhere. So where is that? Oh shoot, we just call it over and over again because we don't have an entry point, right? So we would like to have an entry point. Well, really, we'd like to. Yeah. Because we have support for that, and then we could just put main here or whatever. That would actually, if we added a return, that would fix it. I do not want to do that. Parsing. Stack underflow. Okay, it's not set up properly because the way we're doing things up, but that is what we need to do basically. So we need to generate all of the functions afterward. At the end of the file, after everything else is written, then all the functions go below that. Yeah, then we can call it and return everything, and it'll be fine. We do want to return as well. At the end of a function anyway. Actually, if I just did that, it might actually still work. Hang on. So if I get rid of this and this, and return. Let's see. It's gonna run extra fast, but we're really close here. No, it's still really close. Okay. We do need to return though. So let's see. I did not handle that, so let me handle that. And then type rand. So basically what we need to do is we need to get whatever the value is that you're returning. Put it on the we need to increase the desired stack size. Well yeah. I'll show it in a moment. I need to be right back. Quick break for about 3 minutes, and then I'll get it set up. Okay, I am back. So let's see. Yes, we need to have a return. So we need to basically it's gonna just generate the expiration or the expert and then swap it with the top of the stack, right? So I think when we counter in an end, we do this, and we do this, and block while scope end. Yeah, so how does the scope end? Scope end, stack size. So we need to set this equal to like we need to iterate it one more. Let me copy that so I remember what it is. Yeah, so this basically we need to set state scope, whoops, scope, stack, data. Scope. We don't want to decrement. Count -1. So we do need to check that that is greater than that. Let's bust. So iterate if I want. And we actually want to set. Yeah, we're gonna do plus plus on it. We want to set it equal to. We need to get that value actually. Equals that. Yeah. So there we go. Then we have the value there. And that's the value that we're gonna swap with. Right? So it's actually more like position. And we'll then export on the node value dot export. I can make it as called. So we'll generate the expression, which is stored in the return. And then what else? We need to gen return, right? Which is really just f file ret, and that's it. Okay, ret, and then yeah, so then we need to in swap. Before we return, we need to in swap, right? So gen in swap, state file, and just the top of the stack. So I think we need it as the position. I'm pretty sure we already have that though. So it's gonna do that on top of the stack, and we need to gen pop to pop off that extra value that we have. Right. Okay, I think that is it for that. I guess something like that. Gen in swap. Many arguments. Okay, so it doesn't need what it should be. What? What? File and value. Okay. Okay, gen expert. Okay, yeah, because we need the file as well in the state. Okay, that's what we need. And main is normally a not what? Alright, so I'm missing. Oh, yeah, because I have this here. And that compiles it. So yeah, I still have the issue with the entry point. But we do have the pop and return now, so that should work, and that should set the value on the top of the stack that we need, that we are going to return. But now, now the issue is with the entry point, right? So I can move stuff around. So all of this before that can be moved down here to right before, right? It's going to be end. Move to right there. And we can make this thing. And we can entry point make. So we could do something like that. Again, if I file it, I guess that. Okay. You know, so I'm missing something else on here. 23. That is just a colon, regular colon. And then I think that should give you 10. So 12. Not sure why it would exit with 12. Exit with 3 for some reason. It must be I messed up the order. Okay, it's kind of hard to test, but basically that's something. So I need to save all of those until after, generate them after all the rest of the code. That's really like the only way to do it without making a main function, right? That I can think of. Let me think. Because the problem is we want to skip over it. Okay, I guess I'm gonna do that. So just any functions that we have will just be generated after. And I think that'll work as long as there's like a return and everything like that. So let me try that. But we don't know when it ends, you know? So that makes it kind of hard. What if I just move them after, you know? Like actually in the code. If I place this after, then it's fine, right? Shoot, am I just got rid of it? Oh shoot, but I'm also calling foo, and it's that. So that is also a problem. Why is it exiting with that? Yeah, it's reference before assignment, so we can't do that. Shoot. Right, so that's not gonna work either. Yeah, it's hard to do that. If I get rid of that, it does compile it. Yeah, and it doesn't actually work because foo is there. Why is all this down here? Oh, because we push 0 and that is the variable. Okay. Then if we call foo from here, then it should work. Well, no, it doesn't have all of the variables. Uh-huh. Okay. How can I do that? Without making a main function, what are... Like, basically needs to be at the end of the file. Right? Let me generate it again. Okay, so... like that, and just get rid of the exit for now. With command, I added one. I did add one. It's not very good. I need to work on it, but there is a work command. As long as the bot is still working. It might have, yeah, there we go. That's all it says right now. It doesn't generate a bunch of other ones, but it does. It does exist. So then this has to go at the end. Let's move it down there. So if it was generate at the end, would it work? Yeah, she's exit with 0. Let's add let's add exit with x. We'll see how that works. But we'll change x to 5. No dot. I'm just seeing what the options are, right? And index on array. Okay. Why is that? This exit has to go after that. Does it? Shoot. Right. Well, no, it shouldn't have to because we call it. So, and that should set up the stack. So where does it go out of? Is it here? What? What? Maybe non-type, but family. That? Wait, does it not? Why does it expect that? It was working a second ago. Wait, like that? Huh. That's not good. Alright, I don't know why that happened, but let's see. So let's do anything. Let's see if it's there. No, it is not. So that's 16. Where's 16? Yeah, so y equals y plus 1. So that is actually right. The y. So that's what we print out there. And that's actually what we're returning as well. So wait, but yes, we return it. We do want to discard the value as well if we don't want that value. So this index must be out of range. Is it? And higher. Nope, so that's not out of range. But it's not supposed to be 16. Yeah, because that's what we return. So that's why it is that. Negative 60. But why is it out of range? Wait, now it's not out of range. Wait, what? No, it is still out of range. Hang on. So where's it out of range at? I don't get that. Wait, what? We get there. And then we exit here. So how would it be out of range? Huh? When we call this, it exits. How does this exist? Oh, because we have the print there still. Okay. So let's see. So this is probably what it is then. Right? Yeah. Okay. Okay. Chasm. So this is out of range for some reason. Did we pop too many times here? Oh shoot, because this end, the return needs to be after the end. Ooh. Okay, I see. Let me look at the type A. If it's a function, we want to generate the return. Yeah. Let's get rid of the scope N. Is it in there? Equals block fun. Let's see. If it equals block fun. Right there. Okay, but we need to check it in here as well. So let's look at the scope N, or the type N, that's what it is. So if that equals that, let's actually do block block equals state block stack dot data. Where's my state? Stack dot count. And then we can do that. So if block equals wow, that else if block equals block block. Then we want to do this and fun, and this is where we generate the return. Whoops. Right. So we don't want the return for the actual return. We just want to set up a stack for a return. So we can get rid of that. Let's see. Build that. Stack is undeclared. And block it's like stack. There we go. Kano. And let's see. So it's not going to work. We still have to set up the right. But it should now say the return after the pop and everything. Yeah. So now we'll do that afterward. So it should be set up properly. So now if we move it, actually, what if we just move this? Do entry, we move the push 5 down to there. No, and this is the main. All this. It's out of range. Okay, where is it out of range? I really need a debugger for this. Probably still this one, right? Right. Okay, let's see. And yeah, so it is there. The into 3 is out of range. That is interesting. Is it? Oh shoot! Is it trying to? It's trying to call to the wrong one. Let's see. So we want it to be 5. It's hard to like. I might just need to go through the whole thing. 5, 10. Still out of range. So let's see. If I can get it working, I might be able to get it working in actual code. Might not be able to finish it all though today. So we call it here. Right, so let's go through the stack. So we have here 5, 15, and 15, right? We got 3 things on the stack, right? So 0, 1, 2. So that would already be out of range if we did that. When we call foo, we pop a lot of things. So we indupe the first one. So that's what we set up. So we have 15. And we push 1 and add. Why do we do that? Wait, what is the Oh, shoot, because we do this. Yeah, because that's when we're referencing it. Okay, and that is the y equals y plus 1. That's basically what this is. Then we swap with that. So that is just below the stack that we're going to pop to. Then we pop it, yeah. So we pop off the top element. Wait, maybe we don't want to do that, actually. That last pop. Now that I'm thinking about it. That could be it. Whoops. Because when we swap it, we still want to get rid of it at the end. So I think we don't need to do that. So let's look. Alright, let me just try that, and then I will go through it again. Main. 3, 4, okay. Fire, 10. Still doesn't work. Okay. Let's go through it. So we do this. So the stack right now looks like 5, 15, 15. We indupe 1, so that puts 15 on it. 15 and 1. We add it here, so it becomes 16. And then we swap it with, so 0, 1, 2. So this becomes 16. This one becomes 15. And we pop this one off. Wait, I thought we got rid of that. Then we indupe 1. So that is this one. So 16. And swap 2. Why do we do that twice? Oh, shoot. Because we're changing the value of it. Okay, I see. So it's 16. Swap with 2. So this becomes 16. This one is still 16. Then this one gets popped off. And then we return. So we have these. Right, but this is now indupe 4. So it must be trying to call to the wrong thing. Did we not get rid of all the variables? Actually, that could be the thing. That, ooh. When we reach the end, if it's a function, we want to pop all of the function variables off. Right. So how do we do that? Well, okay. Let me see. What we might have to do, actually, is just have like a separate list of expressions for the function, you know? And that's the whole thing. And then we generate that separately at the end. And that would kind of means we have to change a lot of stuff. So when we get to the declaration, we need the value to be, we need the name, the return type, and the arguments. But then we also need we need this, right? So we have, right here we have nodes. We need those, like a list of those, but as the values. And we need to get that until we reach an end. Right, if that makes any sense. So we might have to do that, actually, now that I'm thinking about it. I don't know if I'll have time to finish that today, but I will try it. So let's go to parse. And actually, first of all, we need to change the function declaration. So func dec is going to have a nodes. Basically, this func nodes. Func dec. Let's see. Struct. Can I do that? Alright, we can actually do that the same way as this. So it can be deck cards. This is the body, right? The body of the function. And we'll just basically recursively call it on this, and we'll append to this rather than the other one that we're appending to. If that makes any sense. Until we reach an end. Okay. I think we can work with that. So when we call the parse function, what we need to do is if we encounter a function deck, right? Type func deck, then we need to parse the body. So we reach the end here. And what we want to do is we want to call parse. Well, actually want to set I want to pass the same tokens, right? And what else do we pass in here? Just the tokens. Okay, but not as a pointer, but we kind of want it as a pointer. I kind of changed everything. So I guess we shoot. Huh. How do I want to do that then? Because I don't have to change every instance where we put tokens in here. Let me think. I want to call it on itself. We also want to update it so that we get like skip. So I suppose right now it returns the nodes. Yeah, and I guess we'll just pass it out again. A pointer, right? And this is the iterations. So, whoops, iterations. Yeah, so to start out, we'll just pass it as 0 or whatever. And at the, we'll do since the start equals tokens not count. And then at the end, whoops, iterations equals tokens, start, tokens not count minus start. So, yeah, that would be however many it is. Or, hang on, is that right? Start is 3, 5. No, we need to do it the other way because start is going to be larger because we subtract it. Yeah, so if it's that, then that is however many we consume. Start minus tokens back down. And yeah, let's do it like that, and then we'll just have to pass that anytime that we call this. Like, more ideally we would pass it as a pointer, but we can't really do that, so we just have to then skip by that. At least for now, until I want to refactor the whole thing like that. Okay, so right here, let's say node.value.deck.body equals parse tokens, and then we want to pass the is equals 0, and we'll just pass the pointer to it. Then for size equals 0, while I is less than iters, plus, and we'll just basically yes, that many times. So we'll just skip over it. That's what we're gonna do there. It's not ideal, but it is what it is, right? Okay. And then if we don't want this though, then we should probably just, check this, right? So if we do if iterations, then we want to do that. Otherwise, like, we can just pass null, and then that will be more helpful. So then when we encounter an end, we need to just need to return here if we're in a function. So let's actually let's do this. I was going to basically check this again. It's fine. We'll just depend here, and return like that. I think that's it. So then we should be able to return. There are a few things. 2 variables to parse. Yeah. So 2, or 1232. Okay. And we need to just pass null. Okay. Func deck args from that. Okay. What? I'm typing nodes. Func deck args. Deck args. We can just cast it though, because it's the same thing. pretty much. Well, it's like exactly the same thing. It's just we had to declare it before. So what if we even just take this and move it up, you know? We replace it with that. If I do that, if I get rid of this and I rename this to nodes, it's the same thing. So, and then replace that with nodes, and then anywhere else where we do that. So, deck arcs with nodes. Okay, and that should work then. Hopefully. I'm not typing it. Okay, so do that again. Deck arcs. How should we use this? Deck arcs. Alright, sounds good for that. And then what is this? I'm not typing it still. Okay, now I can pop. Howdy, how you doing? How you doing? What is up? Alright, so that's safe open. Let me actually. I don't know if we make it here. I is less than. And we just want to think that. Node types root dot data dot type. Okay, like that. And I don't think we actually make that far, so I will show that. But yeah. So when we call this, it might not work. So let's see. Type func deck. And let's see, what is this? That's the wrong place. I need to look at this one. Okay. So we do call it, and we assign to that body equals that, and we consume by that menu. Do we actually make it equal? I would assume not. No. Alright, do we make it to right before this? Yes. Okay. So it's in there that we failed, so we know that. So do GDB, that's right. Break on parts. And run and volcano. Yes. Okay, and then we'll continue to the next one. And that's where we're at. So if we print iterations, we should be able to do this. Iteration. Okay, so it's 0. So we are in the second one. We encounter that. Okay. Where does it actually segfault that? We're at the end. So this does. Oh shoot, okay. I see what's wrong. So we didn't actually push that. Yes. Okay, I see. Yeah. That's what the issue is, because we have the block stack. And we expect that, because we have some other things that we need to do here. So we might need to push, or to actually send the block stack, right? So what can we do here? What we could do, if iteration, so if it's not null, then we'll append to the block stack, and we will just append, block stack. We'll just append that, because the only time we're going to call it, like, this is a bit of a hacky thing, but I'll do it for now. So it will be block func, right? So then we have that there, you know? Yes. And that did not work. Block func int. Alright, so it doesn't like the block func. So what is it? It is block func. So what is wrong with that? Oh shoot, because it needs to be this. And then our value is that. Okay, so we need to do this. Alright, so what if we just pass the block stack, right? Can we do that? Yeah. Well, I think that would work actually even better. So let's see. And let's pass the block stack pointed to it, because we do actually want to pop it up. pointer to the block stack. Then we do have to change everywhere that we use it when we append, because it's already a pointer. And then we can get rid of this. So we want blocks, block stack. And to get rid of this, get rid of that. And we will just pass, we call it 0 initialize one, right? So blocks 0. And then I'm going to have to go through the compilation errors because we have some things there. And that's supposed to be a pointer actually, so we can't do that. So we need to actually blocks block stack equals 0, like that. And then just pass a pointer to that. Okay, build that, and then we have a few range variable tokens, really. Oh yeah, because we do this, that's fine. Root undeclared. Oh shoot, because I did that wrong. Okay. And then block stack. I did that wrong as well. 20, yeah, so I need this needs to be ampersand. Yeah, block stack is the pointer, so 969G. So pointer. Stack pointer. And pointer, so there's going to be quite a few of these, but that's okay. Block stack, arrow count, and arrow count. Okay, let's see where else. DA append. Yeah, so the DA append, any row that we append to the block stack, we need to do that as well. Just search for block stack and see everywhere I use it. Yeah, so this is state block stack. Well, we have it in the state. We do. Wait. Oh shoot, yeah, because that's before we parse. Yeah, so that's why. So yeah, we need to go here. Not in here, so in the actual parsing. So in parse block stack. Parse there we go. Okay, so block stack, let's search for that. Already a pointer. Stack. And it's already a pointer there as well. And let's see, I guess we don't do that. Yeah, okay, so I guess that was it then. Okay, so it does compile, right? It's still saying false though. Alright, let's look at GDB, enable. Let's just run, see where it does, where it fails. Okay, the labels. Shoot, I forgot about that as well. Okay, so why was it an else in the else? We should also check the boundaries there as well, so you know. So if labels path count is 0, then we're switching there, right? So node dot block labels count was, and we got that, and we'll just pass. Okay, so that should fail, right? That's gonna prevent that. Yeah. Okay. So why do we have that, right? Why is it not a function when we type it in? Yeah, it should be a function. So that's not good. So I think we might have passed it before we did that. Let me look. So, it's actually probably because we have to. Wait, hang on. We have to do what? We have to consume a token, right? Before we do that, so let's go to the and I think we need to do token consume before we return it. Is that what it is? No, that's not what it was. Okay. Oh shoot, I know. This, because of this. We need to do this here. Okay. Yeah. If iterations, which it should be, but well, we can just do an assert. So assert iterations. iterations was no. Okay, but it shouldn't be, so I think we should be good. So iterations equals that, and then we can return that. But that. Alright. Insertion failed, unreachable. Okay, so on an open parenthesis. Which one though? So do we not want to do that? Okay. Vardeck, func call, native. And the function call should now contain all of those things. Like the reassignment and everything like that. Okay, so if we actually if root.data I.type equals type func call, then we want to do this loop again, you know, for size t of j equals 0, while j is less than root.data I value func call dot body dot count equals plus, and we need to basically print it like that. So it's gonna be kind of long, but that's okay. Func call body. No, this needs to be root.data I value dot oh, this is not right. Okay, this needs to be what? Body, yeah, and then we need to do dot data j dot type. Okay, yeah, that's not right. I don't remember the name body. Oh no, it's func deck, not call. Deck. Okay, and that is not right. Func deck. Okay, main account, and we should see. Yeah, we have this. Don't know why it's for any of them. Yeah, okay, I see. So we have the var deck and then the function deck, and we have var reassign, return, end, and that's all in there. So if I comment this out, then you can see the difference, right? So we have var deck, func deck, function call, native, and okay, so that's gonna be better. So then we're gonna call the function call recursively. Pretty much is what we want to do. So it's gonna take a bit of wiggling around, but we should be able to do it. So when we encounter a function declaration, we need to generate it separately. So how do we want to do that exactly? Okay. So I think we will have a list of, well, let's see, how do I want to do it? So basically we need a number of functions that we're going to generate at the end. You know, so we want to actually do them at the end. So how do I want to do that? I want to do the rest of them. And then that. Shoot. Okay. I actually have to go about now. So I will probably commit this, and then I will think about how it's going to work. And the next stream is going to be actually getting it to work, you know? We're really close. So we need to basically push it to a stack of the functions. And then at the end, go through each one, and then generate them. But the problem with that then is when we do the function calls, it might not work. No, but if we look in the functions that are queued, yeah. Okay, so that should work. So let's see. Redo the parsing for functions. Alright, yeah, so I will push it now. And yeah, so there we go. That's gonna be about it for today. So thank you for watching, and I'll see you guys next time.